So basically, if we are given any real sequence xn, which is denoted using this symbol, and we say that this sequence is convergent to some real number x, right? We say that if we are given some band, right, of some width, right, of some thickness 2 epsilon, right, this epsilon is just a symbol, right? So if we are given any band of some width 2 epsilon, right, we should be able to find a stage on the x-axis such that after that stage all the terms of the sequence should lie inside that band, right? Now let us see this sequence 5 4 3 4 5 and so on, right? Now I say that this sequence doesn't converge to any real number, right? So let us consider try to understand using an example, right? Now if I consider this point, right, 4.5, and draw a band, right, and draw a band which is very narrow, right, then I can see that none of the terms of the sequence is going to lie inside this band, right? So this 4.5 is rejected. Now if I consider some other point, right, now if I consider some other point, say 5, right, so if I consider the point 5, right, and draw a band with this much thickness, right, I can see that some of the terms of the sequence lie inside this band, like x1, x5, x9 and so on. But I am not able to find a stage on the x-axis. I am not able to find a stage such that all the terms after that stage would lie inside this band. Now for example, if I consider some point here, right, some point here that lies inside this band, I can go to the right to find that there would be a term which lies inside, which lies here, and there would be a term which would lie here, right? So it is always going to be the case that I won't be able to find any stage on x-axis such that all the terms after that stage are fully inside this band, right? These 2 points will always lie outside the band, right? So I can repeat this procedure considering any real number, right? Now I considered 5, I could instead consider 4, I could consider 3 and so on, and repeat this whole process. And by that I can easily conclude that this sequence doesn't converge to any real number, right? Now if I consider this sequence and consider this band, right, consider the band around x is equal to 3 or y is equal to 3, right, around this point 3 with some thickness. If I consider a larger band, then I could fit all the terms of the sequence inside this band. All the terms easily lie inside this band. But even if I consider a narrower band, right, this kind of a band, right, I can still find a stage, the stage being 2, such that from the second term, all the terms of this sequence are going to lie inside this very band, right? The first term is left out, that we can't do anything about it, right? But from the second term, all the terms of the sequence are going to lie inside this band. So this sequence kind of stabilizes after the second term. You could say something like that, right? And no matter how small the band I am going to choose, right, all the terms are going to lie after a stage, and that stage is 2 precisely in this example, right? So I can say that this sequence converges to the real number 3, and this is, by the way, the symbol for convergence. So this sequence xn converges is denoted using this arrow, converges to the real number 3, right? Now you have to convince yourself that this sequence doesn't converge to any real number, right? You can consider any point, and you would have to find a stage such that all the terms should lie inside that stage, but it won't happen, and hence this sequence won't converge at all. Now that is going to be the case for this sequence as well. This also doesn't converge to any real number, right? Now let us consider this sequence xn is equal to 1 by n, right? This sequence is kind of interesting because this sequence converges to the real number 0, right? Now even though we are not going to prove this rigorously, let us try to understand this using 2 or 3 cases, right? Now if I consider the thickness of the band to be 0.2, that is, I'm considering a band centered at 0 with 0.1 units above the x-axis and 0.1 units below the x-axis, right? So if I consider this band, then I would have to find a stage such that after that stage all the terms of the sequence should lie inside that band, right? And I am claiming that n is equal to 11 is that stage, that is from the 11th term, that is the 11th term of the sequence is 1 by 11. So from the 11th term 1 by 11, all the terms of the sequence, that is the 12th term 1 by 12, 13th term 1 by 13 and so on, all are going to lie inside this band, right? Now it is your duty to verify this. The same is the case for epsilon is equal to 0.01, right? So from the 101th term, right, all the terms of the sequence are going to lie inside a band of thickness 0.02 units centered around the point x is equal to 0, right, or rather y is equal to 0. Now the sequence xn is equal to 1 by 2 power n also exhibits a similar kind of behavior, right? For epsilon is equal to 1 by 3, right? The stage that I am choosing is n is equal to 2. So from the second term, all the terms are going to lie inside. And for epsilon is equal to 1 by 12, the stage that I am considering is n is equal to 4. Right. So summarizing this, any real sequence xn, I say that it converges to a real number. And when is it true? If we are given any epsilon, if we are given any thickness for the band, right, then we should be able to find a stage. We should be able to find a stage such that the terms after that stage, right, all those terms lie inside this epsilon band that we are considering, right? The epsilon band that we are considering, that we are drawing around the point x. And if that happens, we say that this real sequence xn converges to the real number x, right? Now, vaguely, if a sequence xn converges to some real number x, then we can think of it vaguely like the terms of the sequence kind of get closer after a stage, right? They kind of stabilize around the point x, right? Now also, if a real sequence xn converges to some real number x, then the same sequence cannot converge to some other real number y,